Have you ever paused to truly consider the incredible world around us? From the invisible dance of atoms that form everything we touch, to the mind-boggling scale of galaxies swirling billions of light-years away, there's an underlying order, a profound elegance, that governs it all. This universal tapestry of knowledge, this relentless pursuit of understanding, is what we call science. In today's video, we're going on an invigorating journey to explore the very essence of science. We'll delve into its fundamental methodology, survey its diverse branches, marvel at its historical milestones, understand the critical mindset it fosters, and ultimately, grasp its transformative impact on our daily lives and our collective future. Prepare to see the world through a new lens. A lens sharpened by curiosity and refined by evidence. At its core, science isn't just a collection of facts. It's a dynamic process, a systematic approach to inquiry and discovery. It begins with observation, noticing a pattern, a phenomenon, or a question about how the world works. From there, scientists formulate a testable explanation, a hypothesis, which is then rigorously examined through experimentation and data collection. This isn't a rigid, linear recipe, but rather a flexible framework that emphasizes critical thinking, empirical evidence, and reproducibility. Think of Galileo, challenging centuries of Aristotelian dogma not with rhetoric, but by carefully observing the moons of Jupiter through his telescope, providing irrefutable evidence that not everything revolved around the Earth. His meticulous observations, though simple in concept, were revolutionary, setting a precedent for scientific inquiry based on what could be seen and measured. The beauty of this method lies in its self-correcting nature. No theory is ever sacred, always open to refinement or even complete overturning in the face of new, compelling evidence. The vast landscape of scientific inquiry is often categorized into distinct, yet profoundly interconnected, branches. We have the foundational physical sciences, like physics, exploring the fundamental constituents of the universe and their interactions, from subatomic particles to the forces governing celestial mechanics. Then there's chemistry, the study of matter and its properties, how substances interact, combine, and change, essentially, the molecular language of the universe. The biological sciences, in turn, investigate life in all its incredible complexity, from the intricate machinery of a single cell to the grand ecosystems teeming with biodiversity. Beyond these, we find earth sciences, unraveling the mysteries of our planet's geology and climate, astronomy, peering into the cosmos, and computer science, developing tools that accelerate discovery across all fields. Consider photosynthesis, a biological process that is utterly dependent on chemical reactions powered by the physics of light, occurring within a planet shaped by geological forces and observed with astronomical insights. These fields are not silos, but rather different windows into the same magnificent reality, each offering a unique perspective that enriches our overall understanding. The story of science is humanity's greatest epic, a continuous narrative of curiosity and ingenuity spanning millennia. From the earliest astronomical observations by ancient civilizations that guided agriculture and navigation, to the philosophical inquiries of the Greeks who sought rational explanations for natural phenomena, the seeds of science were sown. The Islamic Golden Age saw unprecedented advancements in medicine, optics, and mathematics, laying crucial groundwork. Then came the scientific revolution, a pivotal era where figures like Nicolaus Copernicus dared to place the sun, not the Earth, at the center of our solar system, fundamentally shifting our cosmic perspective. Isaac Newton, building on the work of giants like Kepler and Galileo, formulated the laws of motion and universal gravitation, providing a unified framework for understanding both an apple falling and planets orbiting. Fast forward to the 19th and 20th centuries, and we witness breakthroughs like Darwin's theory of evolution by natural selection, Marie Curie's groundbreaking work on radioactivity, and Einstein's revolutionary theories of relativity. Each discovery wasn't just a standalone fact. It was a stepping stone, a profound insight that paved the way for the next, illustrating the cumulative and collaborative nature of scientific progress across generations and cultures. Beyond the accumulation of knowledge, science instills a powerful and essential way of thinking. The scientific mindset. This isn't about rigid dogmatism. It's about embracing uncertainty, fostering skepticism, and valuing empirical evidence above all else. A true scientific mind is constantly questioning, not just others' findings, but its own. It adheres to principles like falsifiability, the idea that a scientific hypothesis must be capable of being proven wrong, and demands reproducibility, meaning experiments should yield the same results when performed by different researchers. This rigorous process, often involving peer review where experts scrutinize each other's work, is what distinguishes genuine science from pseudoscience. It's why scientific theories, like the theory of gravity or evolution, are so robust. They've withstood countless tests and mountains of evidence. This mindset encourages intellectual humility, recognizing that our current understanding is always provisional and subject to revision as new data emerges. Consider how Pluto was reclassified from a planet to a dwarf planet. It wasn't a mistake in observation, but a refinement of definition based on a deeper understanding of celestial mechanics and the discovery of similar bodies. Science is not afraid to correct itself, and in that lies its immense strength. The impact of science is woven into the very fabric of our modern existence, extending far beyond laboratories and textbooks. From the flickering screens of our smartphones to the marvels of modern medicine, nearly every convenience and advancement we enjoy today is a direct consequence of scientific endeavor. Think about global health. Vaccines have eradicated diseases like smallpox and significantly reduced others like polio and measles, saving billions of lives. Antibiotics, a gift from microbiology, transformed common infections from death sentences into treatable conditions. Precision medicine, powered by genetics, is now tailoring treatments to individual patients. In technology, basic research into electromagnetism led to electricity, telecommunications, and the internet, fundamentally reshaping human connection. Space exploration, driven by physics and engineering, expands our understanding of the cosmos and offers new perspectives on our home planet. Furthermore, science is our most potent tool for addressing the grand challenges facing humanity: climate change, food security, clean energy, and sustainable living. Through climate science, we understand the urgency of our environmental crisis. Through agricultural science, we develop resilient crops. And through material science, we create efficient solar panels. Science isn't just about discovering what is. It's about enabling us to build a better future. So, as we've explored, science is much more than a subject. It's a profound human activity, a relentless quest to understand the universe and our place within it. It's a method for questioning, a collection of interconnected knowledge, a chronicle of discovery, and a mindset for critical thinking. Its impact on our world is immeasurable, continuously shaping our lives and empowering us to tackle the greatest challenges of our time. If this journey into the world of science sparked your curiosity, please give this video a thumbs up, share your thoughts in the comments below, and subscribe to our channel for more explorations into the wonders of knowledge. Let's keep pushing the boundaries of what we know together.